Hi guys, my name is Marin and I'm going to be going over the classes of elements. So there are three classes. There are the metals, nonmetals, and metalloids/semimetals. I'm going to refer to the metals and metalloids and semimetals, as one or the other. They're synonymous. So if you hear me talking about one of them, I'm talking about both, just so you know. So I'm going to start off with metals. Metals are all of the elements to the left of the staircase. So just so you know, the staircase is this orange-yellow little staircase-looking group of elements. Everything to the left of that is a metal. There's the bottom pink ones are called intertransition metals. Those are also metals. It's just organized differently on the periodic table because they needed it to fit on a sheet of paper. So they moved them down lower, which is why it looks a little odd. But everything to the left of the staircase is a metal, with the exception of hydrogen. Hydrogen's like a little bit of an odd element, but everything besides that is a metal. Properties of metal that you should know, and you'll memorize these and figure them out farther down the line, but or really not that far, but just so you know and you have them at an easy place. I'm going to go over them really quickly. So properties of metals are they're generally shiny and smooth when clean. So looking at it, if it's sparkly, if it looks metallic, it's a metal. They're usually solid at room temperature with the exception of mercury and gallium. You don't really need to know those, like that they're different, but I think it's a cool fact and good to know if you ever need to know. They are good conductors of heat and electricity. So I envision this as like getting shocked in a door handle. Your door handle is usually a metal. And that's just kind of how I think that it's a good conductor of heat and electricity, just to kind of remember it like that. And then malleable, which means it can be shaped by like beating down on it or forming it with like a roller or something. That's what a malleable is. That's like the property that metals have. You should probably know the definition of malleable just so you know what you're talking about when you say it. And so when it's asked in the test, it kind of makes sense in your brain, like, oh, metals, they are malleable. You can shape them. Stuff like that. It's kind of important to just make a little mental note of. And then ductile is the ability to pull the metal through a wire. And I kind of think about it like this, like if you ever see an open wire, you see like a bunch of copper and other like metallic looking things inside of it. Don't ask me what's in there, but I always just envision it as that's metal. So that's how I think of ductile. Groups that are metals, so again, all in that blue area and the pink, would be group 1, alkaline metals, group 2, alkaline earth metals, group 3 through 12 are the transition metals, which is that big block in the center of the periodic table. And then intertransition metals, which I pointed out, are the bottom pink elements at the bottom of the periodic table. And then groups 13 through 16, just all the elements below the staircase, those are all metals too. So just make a little mental note of that. I wrote that down there just so you can kind of remember that those are also metals, even though they look a little like organized differently, they really still are metals. So don't even worry about that. Anything to the left, they're metals. Just keep that in your mind, aside from hydrogen, but you know, you'll get that. Here's some examples of metals. You can kind of see them like looking at them. They're metallic, like anything you've ever seen that's metal kind of looks like this. Up here, there's some copper, which kind of goes into the ductile in the wire. And then here's like a malleable example because it's super flat. So they definitely used a hammer or roller or something to make it that shape. You can see it's sparkly and shiny over here, and they kind of just all have those metallic qualities I mentioned earlier. So it's important to kind of be able to register that quickly just by looking at it. So next category is nonmetals. Nonmetals are everything to the right of the staircase that I mentioned previously. So that's going to be this whole green bit of elements. I like to point out that there is noble gases right here, and you're going to need to recognize those later down the line. They do become important. But I always just like to mention that just so you can make a little mental note. But everything to the right of the staircase is a non-metal. I like to kind of remember metals are on the left, non-metals are on the right, because there's a lot fewer non-metals than metals, which is pretty apparent here, I would say. So if you just remember there's less non-metals than metals, you're golden. Properties of non-metals, so they're gases or brittle, dull-looking solids. So they look completely different than metals, which is helpful because then you can kind of distinguish it just by looking at it, which is helpful. As I mentioned, they're the right of the staircase, and contrary to metals, they are poor conductors of heat and electricity. So, like, I don't think you've ever been shocked by something that's, like, dull looking, really. So, obviously, wood is not an element, but you're never shocked by wood. An element like sulfur is very brittle and easy to break apart, and it smells horrible, but you're never shocked by it, so it's definitely not a good conductor of heat or electricity, which is kind of how I like to relate to that in the daily life. Groups that are non-metals, so group 1, which is only hydrogen, the rest are metals, but I put that down there just so you remember about hydrogen. Group 17, group 18, which I mentioned previously, are the noble gases, just to make a little bit of a mental note. Again, and then through 13 through 16 elements above the staircase are non-metals, so contrary to the metals, they're above it, and they are in the same group as some metals, but they're separated by the staircase, so it's easy to distinguish which is which in the table. Some examples of nonmetals, so you got carbon, phosphorus, sulfur, you've got neon, you've got all different types of things, and they become a gas. Some cool reactions can happen, like it might be a solid, but when like heat is applied or something else, it can make like a cool colored gas or something like that. It's just fun to see in a lab, which I'm sure you'll do, and I find that really interesting. So that's kind of how I remember nonmetals. They're like weird, I guess. Like looking at them, they just look kind of odd, which is kind of how I distinguish it. And then lastly, the metalloids or semi-metals. Those are on the staircase. So again, this orange, yellow type of color of those elements. They have both physical and chemical properties of metals and nonmetals. So they're kind of like a hybrid of both, which is pretty cool. They've got cool reactions. They look cool. And it's just like fun to see how they're different. And they're right along the staircase, which I mentioned earlier. Groups that are metalloids and semi-metals, they're all in the middle of the groups that I mentioned previously, so 13, 14, 15, and 16. Obviously, the ones that Mr. Sagan gives you are not colored. I think on the ones he gives you, it's like a bolded line that kind of points out the staircase, which is helpful. But if there isn't a bolded line, it's important to know boron starts it and polonium ends it. And then you just kind of follow the pattern of a staircase throughout the rest of the periodic table, which is always helpful, I think, for me, because then you can kind of orient yourself around that and then figure out where other elements are based on that. Metalloids and semi-metals, so this is kind of what they look like. Silicon, antimony, boron, those are all examples of semi-metals. And I think they look cool. They look more like metals to me than non-metals, but they have properties of both, which is awesome because like it's kind of like a fun surprise what's going to happen next. So they're pretty unique and I like them, so I put in a couple pictures and stuff. And then now I'm going to ask you a couple like trivia questions. You can pause the video if you want to go through these practice questions. I mixed in where to find them on the periodic table and what type of qualities you're going to look for them. So if you want to pause the video while I'm blabbering on, feel free to do that and then figure out the answer. And then I'll read them off and then read off the answer when like I pause for a second. So take your time, get out your periodic table and do these with me because I find that to be helpful. The more practice you do it, the better it is. So in which class is magnesium? And it's in the metals. Which class is germanium? Not metalloids. Which class has qualities of two other classes? And that'd be metalloids. What class has the quality ductile? And that'd be a metal. In which class is hafnium? And that'd be metals. Which class is neon? And that'd be non-metals. That's a noble gas, just to keep track of that. What class is not a good conductor of heat and electricity? And that'd be non-metals. In which class is phosphorus? Non-metals. In which class is berkelium? Metals. And here's my colored periodic table in case this is helpful. there is an assignment where you have to color it based on the color key, and I just wanted to add it in here just to make sure you had it, or if it's helpful for you or anything like that. It is important to memorize those labels and those colors because it does help you later, and there are questions on the tests and the quizzes on specific bits of the periodic table, so like where the groups are located, like all of that type of stuff. So just to review it, the groups are down, periods are across. The other ones that are important to know is for the intertransition metals, those names on the bottom. It's important to know those because they'll be referenced in a test or a quiz, and you'll have to know where they are. And they'll be referenced not as intertransition metals, they'll be referenced as lanthanides or actinides, so it's important to be aware of those. So all my advice is study this, understand what everything is, where it's at, their qualities, how to identify them, how to name them, stuff like that. All of that is important. But I hope that this helped. Good luck on your guys' test, and have a great day. Have a great